For many years now, people have used the Doom time demo, usually of Demo 3, as a sort of standard performance test for certain older PCs, and certainly there's nothing wrong with doing that, but I've never made any allusions to liking the game or the engine it runs on, and id Tech's not really my area of expertise, so I've always wished somebody would make something similar for Duke Nukem 3D. Should be pretty easy, right? Well, as it seems nobody else can be bothered to do this simple task, I did it my fucking self. Hello everyone, I'm Zeph, and after 20 years of not touching programming, I've started doing it again because, well, I've made a utility, and it's called DukeMark, and you can download the utility, but you might need DOS4G to run it. So it begs a question, doesn't it, like, how are these machines going to perform? We've got 6 PCs, and it begs another question. How does it compare to Doom's performance? Because it's pretty much an otherwise unmodified build of Duke Nukem 3D, so... well, that's going to be interesting, isn't it? We'll find out. You know, I've been missing a while, haven't I? I'll talk about that at the end, but for now I'm going to hand you to that jerk with the microphone. And no, I don't like him either, but it is all I can afford. Today then we'll be looking at the performance of a few computers with the game in 2 configurations, silent and playable. For the silent configuration, sound cards are disabled, and the game runs in the standard 320x200 buffered mode. Supposedly far from the fastest video mode, but it's the default, and that's the silent configuration, is basically just default everything. For the playable configuration, there's no real consistency, as I'm just using the settings I play the game with on that particular computer. For one thing, sound cards will be enabled, and as we know from past experience, that will affect the performance. Keeping sound and music on can actually consume quite a bit of CPU time, because while it's far from perfect, Apoggee's audio library is quite an advanced piece of kit for its time, being able to plot sounds in 3D space and handle things like echoes. At the end, we'll risk pissing a few people off, because we're going to compare our results to the standard time demo in Doom. But let's not jump the gun. We'll pick on the 2 slowest computers for the moment, my 486DX50 and my U5SD40. Both of these are local bus systems, but my DX50 uses an older motherboard which is far from the fastest available, though it does have the Chips and Technologies WinGen VGA card, which might help it somewhat. The U5 has an ET4000, it's a W32P with 2 megs of RAM, which is usually about neck and neck with the C&T when they're tested in isolation. The U5SD uses a late VLB motherboard from the mid-90s anyway, which bursts much better performance usually. The ALU is also faster on the UMC processor than Intel's, but as its floating point unit's been disabled at the factory, it might well chirk if build starts doing a lot of floats, as they'll have to be running software on the ALU, and this will take significantly more cycles to complete than it would on a dedicated FPU, which it goes without saying is something the Intel processor has at its disposal, and that might just claw things back for it a little bit. My tool is called DukeMark. It's pretty impressive, isn't it? Can't say the same about this benchmarking utility I've come up with though. It's pretty simple to use. You might need the DOS4GW extender in the directory to run it. All you do is pass it a command line switch, which decides whether you want the readouts on the left or the right, and then tell it which demo file to run, bench 1 through 3 at the present time, but I'd kind of like to add more. The readout shows the current frame rate in pink, basically how many times the game module has called the room drawing function per second. My logic keeps track of the lowest sample taken in red, that would be the minimum recorded frame rate, and the fastest in green. Blue is the average over time, and it collects about 4 samples per second, though the total sample count at the end can vary if your computer stalls a lot. The numbers in yellow just show the screen size, the mode, the HUD size, detail level, sound and music settings, things like that. It kind of serves as a bit of an anti-cheat because you'd be able to tell if somebody was turning the detail down or dubbing sounds over when they weren't really using the sound card and things like that. Either way, we can see the noted float crunch happening at the back of the bookstore. This nets us our lowest sample on both computers. As we predicted, the UMC suffers the worst due to its lack of working FPU, dropping to 5 frames a second in this spot, though the Intel sinks to 8 here. Now, how could we predict it would happen here? Because there are slopes over here, and unlike Doom, which seems to use no floats at all in its retail version and can't draw slopes anywhere, Build uses floats for sloped surfaces. It actually does some pretty magical and mystical things to achieve this, and not many game engines of the time would have even considered it, but, well, that's why Build's cool, I suppose. In line with other predictions, our run finishes with the U5 being the faster machine on average, with a max of 32 frames per second and an average of 15. Though it's quite close, as the DX50 peaks at 30 and it can average 14. This trend persists with the game on playable settings, though the score drops for both computers due to now having to run the sound hardware. Generally, I would have shrank the screen a bit to negate this if I was just playing the game, but I didn't do that today and just left things at defaults. Pretty much everything's on defaults today unless stated otherwise. Keep in mind the game's box has an Intel DX266 as its recommended processor, and I wouldn't be surprised if the Atomic Edition's requirements were a little bit higher, which is what DukeMark is based on. Or more specifically, the Plutonium pack, I guess, as it's built on 1.4. That's all we have the source code for. We can try some slightly quicker machines then, something you'd maybe actually want to sit and play this game on for a long period of time. Intel versus Intel in this stage, in the form of an 83 MHz overdrive against a 66 MHz Pentium. The overdrive has a PCI ET4000 and the P66 has a PCI Trio. Both these cards actually can do some pretty wacky and wonderful things, but none of those really matter as the game's completely unaware of this and it will just use the VGA chip. And, well, we know there's not much of a gap between these two solutions. We did discover long ago, though, that the overdrive often comes out as the faster CPU of these two, being based on the later P54 core, using less electricity and having twice the internal cache. But then we also know my P66 is an unusually strong machine for Socket 4, because it isn't stuck with Intel shit chipsets and motherboards that I firmly believe are responsible for ruining this platform's reputation. I suppose it's worthy of note that while the pod has a fairly standard 32 megs of RAM and 256k of write-through external cache, the P66 has a colossal 128 megs of RAM with a 1 meg external cache, as well as exceptionally fast SCSI hard drives. Now you might have noticed that one place Build suffers is pulling things from the disk into the engine's cache system, a totally different thing to the PC's hardware caches, and indeed you'll have spotted the cache icon in the lower right of the screen when this is happening. Our SCSI hard drives might just be quick enough to offset this, but then the lower latency of the IDE drives in the pod might just claw it back. The reads for Duke 3D tend to be small but quite frequent, and SCSI doesn't really lend itself well to this in my experience. It's much better at long sequential operations, and IDE, despite being a lower performance interface, does tend to have a little bit of an edge in that kind of thing. At the end of our run here, the minimum frame rate is as narrow as makes no difference, with the pod at 24 and the P66 at 25. I bet you can't guess where that happened. It's always going to happen in that spot, because there's slopes everywhere, and if the mirror through that crack in the wall is ever technically visible, everything's going to get drawn twice. Interesting how close the number is though, but that lines up with testing we've done before, where, well, the P5 core's actually a bit quicker than the P54. It's the clocks that win it for the P54s, and of course they were designed to scale that way, so it's fine. The gap does open up in the max FPS recorded, as the pod manages a respectable 87 frames a second, which is faster than the monitor's refresh rate, so you wouldn't really notice anymore, while the P66 breaks 3 figures, almost doubling the monitor's refresh rate at 106 frames a second. The pod can't average as high either, it only does 43 frames a second, and the P66 can achieve 49. It's not a huge gap, and at this higher frame rate, us old-timers probably wouldn't really notice unless we were looking for it. Keep in mind, 15 frames a second is perfectly tolerable by my standards, because I come from a time when fast computers cost a lot of money, and you just had to make shit work and put up with it. You just kind of sat there and faffed about with settings until you found ones that were a bit less shit than all the other settings you used. Do remember, though, that both of these computers are older than the game, and yet exceed its system requirements by quite a margin, which I think the performance here reflects quite well. Unfortunately, the soundscape in the pod wasn't working on the day. Who could have seen that coming? Piece of fucking shit. So I could only get playable settings from the P66. Go figure this hearts it as the minimum FPS drops to 20, the max to 101, and the average to 43, which is actually higher than the max frame rate in Doom. A lot of this performance hit will be coming from the music card, the TBS Maui, which is horribly underpowered and drags the whole PC down it whenever its crappy 68K microcontroller stalls out, which it does quite a lot. I mean, it was posited as an affordable wavetable card, and this computer's now over 30 years old, so if I really cared about this sort of thing, I'd probably just use a faster machine. You know, we could do that. We saw the Cyrix 686 a while ago. It's the original P200, not the PR200 or the MX or anything like that. It runs at 2 times 75 MHz. It's a 150 MHz CPU. It is equipped with Amiga SYS onboard VGA solution, which is built into the chipset and shares its RAM with the system. We call that UMA, Unified Memory Architecture. It's still a thing on cheap computers, and it still doesn't perform anywhere near as well as a dedicated card, but it works. I mean, this is a computer you would buy at a department store, so it's not really tempered for high performance. My K5 PR166 at 116 MHz also uses a SYS chipset, albeit an older one, and it makes use of an ATI All-in-Wonder Pro, which, go figure, has a Rage Pro chip on it. Yeah, it got a slight upgrade from that Max 64 card when that started wigging out, and a friend was getting rid of this thing because he has no interest in video processing hardware. His loss, I suppose, because I find that sort of thing quite fun. Both machines actually hit the same minimum frame rate of 42 frames a second. The K5 can reach higher peaks though, as the Cyrix tops out at 87, where the K5 hits 120 frames a second. I have a feeling the onboard VGA of the Cyrix is actually the limit in there, and not the CPU. But the hit is enough that the Cyrix averages out at 62 frames a second, and the K5 at 73. I do feel like if these machines use comparable video cards, the numbers would be a lot closer, and just maybe the Cyrix might even pull ahead, as it's far more competent a CPU than people often give it credit for. For better or worse, I don't have the machine configured for performance, and instead it's a working model of a computer you would have bought in the lower price ranges at the time. Both machines are comfortably outrunning the monitor anyway, so it doesn't really matter. Either way, things slow down as expected in playable settings, which this time we could push up to 640 by 400 if we wanted to, and the game would stay playable. I've been freezing the final frame of these demos to make the video more presentable, but if you wondered, yeah, you do get a readout on the command line when the game closes. We could try 6th generation computers like the Pentium 2 and the K6, and those are what I'd actually recommend for playing build games, as they let you crank resolutions up a bit silly, but as the results here are so fast, that's all we need to know is fast. Basically, a Pentium 2 or a K6 is going to run Duke Nukem 3D quite well, unless it's got weird hardware that doesn't agree with the game somewhere. And now, we're probably going to piss a few people off, because we're going to test Doom. There's actually something interesting that we can gain from this, because Doom uses an older engine, written by multiple revered programmers at an established game company, whereas Build was written by a teenager from Rhode Island called Ken Silverman. Doom claims it will run on a measly 386, whereas Duke asks you to use a decent 486 machine. Both engines use sectors, but that's really where the similarities end, as they're formatted completely differently and their rendering code is really rather dissimilar. For years, I have maintained that build is simply the faster of the two engines, and in doing so, I've endured being laughed at, been called all sorts of names, and being shunned as usual. I mean, I'm quite used to that now, given I'm not allowed in really anywhere, but at least I made an impression. It's funny to say how technically I'm a smaller channel, and yet pretty much everybody in this hobby who's been in it for a while has heard of me. I think that ought to tell you something. On the U5, it seems these other people might be right, as Doom can average 21 frames a second, while Duke reaches 15, though that gap is really quite small, you have to admit, given build uses floats, and Duke's game loop is probably longer than Doom's, not to mention that, floats or not, Duke's geometry is more elaborate. In short, Duke's game module has to do more things before it can even think of calling the engine up to draw things, and the engine that it's calling up is more advanced. If we use playable settings, both games lose 3 frames a second. Now, a lot of this loss is going to be the audio and music system in both games, and we know for sure the one in Duke is more advanced and it can mix more sounds at higher sample rates, so remember though that Doom claims it'll be fine on a 386, whereas we're below the recommended CPU for Duke Nukem 3D. I mean, my U5 here only runs at 40 MHz, and well, it might be a fast 40 MHz CPU, but it's still a single clocked SX class computer. I'm not convinced you'd want to sit through either of these games on this computer if you want the best experience, but you certainly could do it if it was what you had at the time. We really do need more data, so how about that Pentium 66? Oh dear. Oh dear. 37 frames a second for Doom and 49 frames a second for Duke. Things might change if we turn the sound on. Oh, I don't know about that though. 34 frames a second in Doom. If I really mess about with the machine, I can just squeeze 36. But Duke Nukem 3D gets 43. Who would have seen that coming? And I can actually leap farther ahead if I start playing with visa modes and fiddling with settings. It's really not looking very good for the IdTech engine there. That's pretty miserable, actually. If we move up to the K5 then, Doom can average 48 frames per second. Duke can average 73. 73 frames per second, a whole 52% faster than Doom. You really have to wonder what would happen if Duke's game loop was as simple as Doom's, and if the geometry was identical. I mean, we could try that someday, porting a Doom map to Duke and running this test on it. Maybe we ought to include that in a future release of DukeMark. So what happens on playable settings then? Can Duke 3D keep its lead here? Doom manages 45 frames per second, where Duke Nukem 3D will nab 54. It's still faster, and anyway, Doom's capped at 35 frames per second in normal play. Oh dear, that is going to be bitter to swallow for some. They are going to kick and scream and chirk and try spitting it out, but you're going to have to swallow it because I was right. Builds the faster game engine when it comes to putting a picture on the fucking screen. So everyone who ever laughed at me, and everyone who ever made fun of me and kicked me out of discussion boards and kicked me out of Discord servers and insulted me and whatever the fuck else you tried to do, yeah, chirk on it. I've done this a long time, and I get accused of speaking in assertions, but I speak in assertions because I know what I'm fucking talking about. I've tried being humble for all these years, and I can't say I've always been, but I've tried to be, and I'm not going to do that. On this occasion I am going to be cocky and smarmy and fucking arrogant, because I think I've earned the right to do that for once. I think just this once I deserve a little moment of that, because I was proven right, and I proved myself right, and it didn't take a lot of work. The code I wrote for this piece of crap tool will fit on one screen, And it's not even that efficient. It was just slapped together in a few minutes. And it really makes you wonder, doesn't it? Did somebody else try this somewhere down the line, run it not like the numbers that came out, and tried to brush it under the carpet? Because there's this real sort of circle jerk about Doom and its engine and really just id games in general. And I don't get why, because nobody fucking plays them. I remember live streaming Doom on the second channel years ago, and as soon as you get past the third map, nobody knows anything about it. I replayed it recently over there, start to finish, more than most people have been through that game, and it wasn't really that fun of an experience. So I know what I'm talking about. I actually know, and I have tested this, and you can download my tool and test it for yourself. The source codes are, build it for yourself, and you'll see I'm not cheating, because I don't feel any need to do that. Rather odd though, how there's this, it's so revered Doom, and the people who made it, I've never made any pretense about it. I've insulted these people, I've slagged off their workmanship and the stability of it, which is generally poor, and the performance is just ghastly a lot of the time. And all this time I was fucking right. And when you've got an overinflated ego like Romero or Carmack, how do you think that's going to feel for them? You know, how do you think they felt back then? Because I'm sure they knew about this back then, that they just got their ass handed to them by a teenager. Yeah, that's got to be pretty crappy feeling, hasn't it? Got to be a pretty crappy feeling being outsmarted by me as well. You know, for somebody somewhere on the internet who's ragged me for being like, no, build's definitely faster. Maybe it's not conclusive. Maybe thus far it's not conclusive. Maybe we need to test it again. Maybe we should convert that map from Doom into Duke Nukem 3D, make a bench demo for it for my tool. You know, do a DukeMark 2.0. I'd like to quite like to get graphs in there using the draw line functions that the engine has. That could be quite neat. You know, we can track the frame rate over time. That would be pretty interesting. But I'm getting ahead of myself. Maybe we should do that though. Maybe we should. Maybe you don't want me to do that, because I don't think that's going to hinder the build engine. I think putting a map like that in the build engine in Duke Nukem 3D, I think will just help it more than anything, and we'll just see a repeat of what we saw today. And maybe we should test on some other PCs. Maybe we should test on a DX2. That was a fairly common configuration. I don't have one, but I can certainly stick one together. I could throw a DX2 in. We'll put one in the U5 machine. You know, that was the one machine that Doom won on. That was the one machine that it won on. And I did test on more machines than I've shown in this video. So maybe we put a DX2 in there, see if it can still win. Because I wouldn't count on it. I really wouldn't count on that. I just think you're going to keep seeing the same thing over and over again. Who knows? Let me know if you want me to test that. And the great thing with my audience is actually, you know, they're a pretty smart bunch. And they're pretty logical. And they're pretty open to discovery. You know, pretty open to, well, I didn't know that. And there's a lot of shit I don't know. And I don't like not knowing. It's the only thing that frightens me, is not knowing. So I like to find stuff out. Which is kind of why I wrote this tool, because I wanted to know. And now I know. And now everybody else knows. So it's pretty neat. Yeah. So what were your thoughts? Did you think Doom would be faster, or did you think Build would be faster? Well, you're one of the few like me who thought, because I know I wasn't the only person who was confident that Build was a faster engine. Let me know. I want to know. In the meantime, yeah, where have I been? Usual stuff. Busy schedule. Dental problems. Health problems. So, nothing very interesting. Been active on the second channel still. It's been a struggle at times with how things have been going this year, but I've been keeping active over there. So if you're ever missing me, then you can always check over there and get bored and never return. But yeah, I don't know. But I'm Zeph. This was a fun little experiment. This was quite a fun one. You know, and as I say, you can download the tool. It's on ModDB. It's on my web server. It's not hard to find. Not hard to build it yourself if you want to. Source code is included. Only modified that one file. You can drag that straight in a Duke 3D source release. Type WMake, and you'll have DukeMark, which will be identical to my executable, but if you don't trust me, you can go and do that. Just end up trusting me. Because, as I say, I don't cheat. I don't gotta cheat. Don't need to. Feel no need to do that. I feel kind of bad for being all cocky and shit, man, but... Again, maybe I don't. Given the treatment I've had in a lot of places over the years... Nah, I actually don't feel bad. The feeling bad's gone away. Quite quickly, actually. I was right. It feels good. Vindicated. Exonerated. Let's have some long words like that. Let's just throw them in there. But no, seriously, it was a fun experiment. It was quite interesting to see. Even I was surprised, actually, by the gap. I was quite surprised by just how much faster build was. I mean, on the K5, though, more than 50% faster. That's not small. That is significant. That's really significant. It makes you wonder, doesn't it? Like, you know, it does make you wonder. Did somebody else experiment with this and not like it? I don't know. Don't know. Who knows? But, for the time being, I'm Zeph. Thanks for watching. And I guess I'll see you in the next one. I'm not sure what that will be, and I'm not sure when it will be, because I'm going right back into a busy fucking schedule until the end of the year, but I'm sure I'll be back at some point. I'll try to be. Might do more of this. Let me know. As I say, let me know. What, shall we do more of this? Shall we try the whole putting a Doom map in Duke 3D? Shall we try a DX2? Is there any specific sort of platform you would want to see this run on? I mean, I own, you know, everything from 8088s to K7s, so just about. There's a few things I don't have and don't really want, but well, most things there, so yeah, possibilities are quite broad. Well, anyways, I'll see you around. Thanks for watching. Ta-ta.